Hi everyone, I'm going to give you an overview of my program that I'm going to use for the temperature thermometer, I guess, simplest terms. First thing is I'm establishing the input voltage, which is going to be the pin. Then I'm going to have the array of temperatures, which is where I'm going to be able to store my temperatures. Then I'm going to have the deltas. These are going to be the floats that are carried around and established later. These deltas are what I'm going to use to determine if something is stable, if a temperature reading is stable. Here we have a section of code. This was borrowed from the source right over here, but this is, well, you don't need to see all that. It's included in the code in case you want to check it out. This converts the voltage to a temperature reading. Over here we have a variety of source, booleans, ints, and floats. These are going to be used in various ways throughout the code. First thing we do is establish we have a serial interface over here. Second thing we do is we classify a program called a serial event. This is going to be ever searching for a program and running in the background, or be checked every round of it takes. If this is ever triggered, then it's going to stop the code and exit out, and that will be our interrupt. The next thing we have here is we start the program and we say if there is a serial interrupt at any point in the code, then it will apply a stop here and I'll stop the code over there. This is where it's applying the stop. If that's not the case, then it's going to start counting the loops of where we're going, and it's going to take the temperature reading, and it's going to apply the temperature and put it in whatever the current temperature read is, going to put it inside the temperature array. The delay time over here is the once every 10 seconds, which we established earlier. And this is just what, if it is a stable temperature, it's just going to give the user a feedback for the current temperature reading is. If it's, so over here, before we can use that section of code over here, we have to establish, is it a stable temperature? If the temperature is not stable, which is the default for the boolean, it will run through this code, which it'll go through, and if it has at least 10 temperatures, if it has at least 10 samples, if it's gone through the cycle at least 10 times, then it's going to compare 3 of those, get those 3 deltas, and if these deltas are within the delta max range, and I'm running it at 1 degree Fahrenheit, then the temperature is stable, it's true, and then it can start running the code up there. And down here, if the temperature is stable, then it's going to take 3 bits of data. First bit is going to be the running for 5 minutes at ambient air temperature, and that's just going to run through, and we're going to give a printout of what the current temperature is. Then it's going to ask the user to give some sort of input, serial input, any key except S, because S is the exit key. And once that's executed, it's going to run for 5 minutes every 10 seconds and cooling, and this is when it's in the fridge. Finally, it's going to stop reading, just like before, and it's going to ask the user to remove the Arduino from the refrigerator, put it back in ambient air temperatures, and then give a serial input, which will allow it to start taking data again. It'll run for 5 minutes again. After these 5 minutes, it's going to end the program, at which point the file will be executed. So to give you a little overview, we're going to run this program. However, I shortened the number of readings from 60 to 3 just so you can get a quicker overview. Here's it running the initial temperatures. It's run at least 10, so it's comparing them. It's determined that it's stable. Now it's asking for any key. It ran its ambient temperatures and its cooling temperatures. So now it's asking for the second round of ambient temperatures. And now the program executed. Thank you very much. That is my program.